Hey guys, welcome to this lesson where today we're applying systems of equations, which is really just us reviewing how do we graph and find the solution, how do we use substitution, how do we use elimination, a little mix of everything. So in this booklet that I have here, it says it is best to use each strategy to solve a system when. So think about what a system would look like if graphing was like the ultimate thing that you would do, that you would look at that system and say, hey, I'm going to graph this system because it looks like it's set up for graphing. That would most likely be because the equations are in slope-intercept form. They look like y equals mx plus b, like this y equals 2x plus 1. Maybe they're in standard form. Remember, it's really easy to graph in standard form when you can find the x and y intercept. So it's possible that it may be in that form. You may say, you know what, I want to graph these and see where they intersect. Substitution is going to be where you see a system and either one or both equations are already x equals y equals. Remember, we need that to do substitution. We need either one or both of the equations to be x equals or y equals. That way we could substitute everything that x is equal to or y is equal to in for that variable in the other equation. And then elimination. Elimination is the last topic that we already learned. It is always used in the problems that we've done when both equations are in standard form. They look like ax plus by equals c. Everything is lined up perfectly for us to either add the equations together, subtract, or maybe you have to multiply one of them to make it actually happen. However, each strategy will produce the same solution, and we've learned that if we were to graph a system and solve it by substitution, we're going to get the exact same solution. So that's what this booklet is all about. It's about taking each one of these problems and solving it in two of these different ways, and we're going to get the same solution. Let's take a look. So problem number 1 is a translating problem. It says 2 times a number x plus a number y equals -4. 3 times a number minus y equals -1. So if I wanted to translate that first equation, it would look like 2 times a number x, so 2x plus y equals -4. My second equation, 3 times the number minus y equals -1, looks like this, 3x minus y equals -1. I have two equations that are in standard form. If I wanted to graph these two equations, the first one looks pretty good because I could find the intercepts, or I could rearrange this equation and get y by itself. So if I was to rearrange this first equation, 2x plus y equals -4, to get y by itself, we would subtract 2x. And so that first equation would really look like y equals -2x minus 4. Second equation, if I wanted to get y by itself, I would subtract 3x, but then I'd be left with a -y. And I'd then have to divide everything by -1, which means that my new equation would be y equals positive 3x plus 1. Go ahead if you have this form with you and graph those two equations and press pause and then press play when you're ready. Otherwise, continue to look on. Here is what this would look like when graphed. This equation here that I'm focusing on is a y-intercept at 1, a slope of 3. This equation, I'm going to color code it for you. This equation here in red is this equation, y equals 3x plus 1, whereas my other equation, the first one, y equals -2x minus 4, is the other graph. I'll color code that blue. It has a y-intercept of -4 and a slope of -2. Look at the intersection. What are the coordinates of that intersection? It's at -1, -2. And so that is my solution. This system, originally the way the system looks like it's beautifully set up to solve by elimination. If I wanted to solve this system by elimination, I'm going to recopy that system here, 2x plus y equals -4, and I'm going to add that to the second equation, 3x minus y equals -1. What we learned in elimination is that when you have coefficients that are opposites, so the coefficient of y is a +1 and a -1, those are opposites. It means that when I go to add them together, they're going to eliminate out because it really just adds up to 0. What I'm left with now is that 2x plus 3x is 5x, -4 plus -1 is -5. Divide both sides by 5, and we end up getting the x value of -1. We know that after we solve for x, every solution is an ordered pair. I need to find my value of y. I can take either one of these equations and plug in this -1 in for x to get my y value. I chose the first equation, 2x plus y equals -4. Since I know that x equals -1, I'm going to go ahead where I see x, I'm going to substitute in that -1. 2 times -1 is just -2. In order to solve for y, I would add 2 on both sides, and we end up getting y equals -2. Look at the solution, -1, -2. We got that from elimination. Look at the graph that we did. We got the exact same solution. Not a coincidence, it would always work out that way. So my solution would mean that the numbers that are talked about in this problem are -1 and -2. Awesome. Over here to the right, an online music app costs $1 and each song download costs $3. Another app costs $5, more expensive, but it's only 50 cents per song download. Which app is more affordable? So if I was to look at this problem, I'm just going to move my screen. The first equation, an online music app costs $1 and each song download costs $3. The slope is the number that continually is changing for how many songs. The $1 is a one-time purchase. That's my y-intercept. My 3 is my slope. So my first equation would look like y equals 3x plus 1. Whereas then my second equation, another app costs $5. That's my one-time purchase, the $5. That's my y-intercept. But 50 cents per song, that's my slope. So that second equation would look like y equals 50 cents x plus 5. If you have the sheet, go ahead, pause, and graph. If not, you can take a look at my graphs here. I'm going to color code these for you so that you can see which one is which. Y equals 3x plus 1 means we have a y-intercept at 1 and then a slope of 3. So this graph that I'm kind of highlighting in red is that first one. Sorry about that last point. And then the other equation, y equals 0.50x plus 5, that has a y-intercept of 5. 0.50 is really 1/2. And a slope of 1/2 would tell me from that point to go up 1 to the right 2, up 1 to the right 2. Now, I definitely see that there's an intersection. However, I'm kind of having a hard time figuring out what are the exact values of that intersection. I'm not 100% sure. But if we use substitution, which this system is beautifully set up for because they're both set equal to y, I can take everything that y is equal to in the first equation. Let me highlight it. Since y is equal to 3x plus 1, then that means where I see y in my other equation, I'm going to replace this y with 3x plus 1. So substitution is going to work out so nicely. So this would look like 3x plus 1 is equal to 0.50x plus 5. You just now have a basic multi-step equation with variables and numbers on both sides. I could subtract 0.50x on both sides and get $2.50 x plus 1 equals 5. Subtract 1 on both sides. Divide both sides by 2.5. We end up getting x equals 1.6. And if I look at my intersection, I would say, yeah, this coordinate, this intersection here, does look like the x value would be at 1.6. Like it makes sense. Now that I know what x is, I need to find y. Lucky for us, both of these equations are y equals. I can plug in that 1.6 into either one of these equations for x to get my y value. The first one looks kind of friendly, so let me stay with that one. Y equals 3x plus 1. We know that x is 1.6. 3 times 1.6 is 4.8, and 4.8 is 5.8. So my intersection is at 1.6, 5.8. If I look at my intersection on my graph, that looks right where 1.6 comma 5.8 would be. So what this means is once you buy 2 songs, the second app is less expensive. You can see that these lines intersect at this point. At this point, they would cost the same, these 2 apps. But the moment you wanted to buy 2 or more songs, so here's where 1 song would cost, here's where 2 songs. 2 songs on the second app is cheaper than 2 songs on the first app. If you only wanted to buy 1 song, the first app would be cheaper, but the moment you go to buy 2, the second equation is forever cheaper. Number 3, at a clothing store, t-shirts cost $10 and sweatpants cost $15. If Autumn spends $220 after buying 16 items, how many did she buy of each? So I'm going to let the amount of t-shirts we buy be X, and the amount of sweatpants that are purchased stand for the letter Y. T-shirts cost $10 and sweatpants cost $15. She spends $220 in total. So my first equation would look like 10x plus 15y. So $10 per t-shirt plus $15 per sweatshirt is equal to that $220 cost. She buys a total of 16 items. So X amount of t-shirts plus Y amount of sweatpants is equal to 16. This is my system here. Now notice I did not give us a graph at all because I just want to practice substitution and elimination. The only way to do substitution is if one of these equations is x equals or y equals. We don't have that. However, I think we can agree that the second equation is perfectly set up to either have x or y by itself. Does not matter if I get x or y by itself. Here I chose to get y by itself, which I subtracted x. So it's y equals negative x plus 16. So now for substitution, this means since y is equal to negative x plus 16, where I see y in the other equation, I'm going to replace that equation. So now my first equation would look like this: 10x plus 15 times negative x plus 16 is equal to 220. If you want to pause the video right now and solve this and then press play and check to see how you did, please do. After doing some distributing and solving, we end up getting x equals 4. Once we know what x equals, we would then take that value of 4 and substitute it back in for x into my y equals equation. So since I know that y is equal to negative x plus 16, that means that y is equal to negative 4 plus 16, which is 12. And I end up getting a solution of 412. 4 t-shirts and 12 sweatpants. That's a lot of sweatpants. If I was to take this system, 10x plus 15y equals 220 and x plus y equals 16, I might say, hey, they're both in standard form. Let me solve this by elimination. So to solve by elimination, I would set them up and I would notice that I can't just add them and subtract them the way they look. They don't have coefficients that are like or opposites, but we can make that happen. I know that if I wanted my 10x to get eliminated out, that this would need to be a negative 10x down here. In order to make it a negative 10x, I'm going to multiply the entire second equation by negative 10. If I do that, I would then get negative 10x minus 10y equals negative 160. Now that my equations have coefficients that are opposites, I can go ahead and add these two equations together. My x's eliminate out. 15y plus negative 10y is 5y. 220 plus a negative 160 is 60. Divide both sides by 5, and we end up getting y equals 12. Well, we already knew that. Now I know that y is equal to 12. I need to solve for x. I may as well use that really easy basic equation we had here. X plus y equals 16. I'm going to plug in 12 for y, and I end up getting x equals 4. And so again, my solution is 412. So that would mean that Autumn bought 4 shirts and 12 pants. Excellent. Over to the right-hand side. At a bake sale, cookies cost 25 cents and brownies cost 35 cents. If Nathan spent $3.15 and bought 11 treats, how many did he buy of each? This is going to be set up really similar to the sweatpant and t-shirt problem. So we're going to let cookies stand for x and brownies will be y. So it's 25 cents per cookie, so 0.25x, plus 35 cents per brownie, so 0.35y. And the total cost of these together is that $3.15. If he bought a total of 11 treats, that means the amount of x cookies plus the amount of y brownies equals 11. You're going to see the way this gets solved is basically the same as it got solved in the previous problem for substitution. First, I'm going to set the second equation to y equals. I could have done x equals. I promise you I'll get the same final answer. This now means if I get y by itself, that wherever I see y in the other equation, I'm going to be able to substitute in negative x plus 11. So now in that first equation, where I see the y, I would replace that with negative x plus 11. Again, I would pause right now to solve this and then press play to see if you get the same answer as me for x. Otherwise, after distributing the 0.35, combining like terms here, 0.25x minus 0.35x is negative 10x. If I was to subtract $3.85 from both sides, I would end up with a negative 70 cents over here. Divide both sides by that negative 0.10, and I end up getting x equals 7. After all that messy, dirty work, it is so easy now to get y. I'm going to take my equation of y equals negative x plus 11. I'm going to plug in my x value of 7. Negative 7 plus 11 is 4. And so my solution is 7, 4. If I was solving this by elimination, it might be a little bit more annoying considering that we're working with all decimals, but it's not impossible. I would want to multiply this entire second equation by a negative 25 cents to get negative 0.25x minus 0.25y, and then that negative 25 cents times 11 is negative 2.75. When I do that, now my x's are opposites, the coefficients are opposites, so it would eliminate out. 35 cents y minus 25 cents y is 10 cents y. And then 15 minus 2.75 is 40 cents. And then if I divide both sides by 0.10, I end up getting y equals 4. You know what's going to happen next. Y equals 4 gets plugged into this equation, and I end up getting that x is equal to 7. So that means that Nathan bought 7 cookies and 4 brownies. These two problems here are incredibly similar. The only difference is that the second problem had just a lot more decimals in it. Last two problems. A medium pie at Olivia's Pizza Shop costs $6.80 plus 90 cents per topping. A medium pie at Nathan's Pizza Shop costs $7.30 but 65 cents per topping. So Olivia's pizza is originally cheaper, but the toppings are more expensive, whereas Nathan's pizza originally is more expensive, but the toppings are cheaper. The topping, the word per for topping, per is going to be your multiplier. So I know that my 90 cents is my slope, whereas the $6.80 is the one-time purchase of the pizza. So my first equation for Olivia would be y equals 90 cents x, so it's 90 cents per topping, plus the original $6.80. Whereas Nathan's equation would be y equals, his per topping is 65 cents, so 0.65x, and then plus the original cost of the pizza, $7.30. Now I do have a graph here, but we're not going to graph it. Don't tell anybody. It's a little obnoxious to graph. It's not impossible, but you know what? Let's just do substitution instead, considering that these two equations are already y equals. So since y is equal to 0.90x plus 680, that means where I see y in my other equation, I'm going to get to just plug all of that in for y. Substitution will be the easiest way for us to graph it. So, to solve it. So that means that 0.90x plus 680 equals 0.65x plus 730. Again, this is just a multi-step equation, so you may want to pause right now and see if you can solve this, and then press play. I subtracted 65 cents x on both sides of this equation. Then I subtracted 680 on both sides. After finishing this up and dividing both sides by 0.25, I ended up getting x equals 2. I would then take that 2 and substitute it in for x into either one of those equations. It looks like I chose Nathan's equation, the second one. I plugged in my 2 for x. 0.65 or 65 cents times 2 is $1.30. $1.30 plus 730 is $8.60. So what this is saying, this intersection, $2.82, $8.60, means that if you got 2 toppings at either pizza shop, at Olivia's Pizza Place or Nathan's, they would cost the same price, $8.60. And that's what I wrote here. 2 toppings would cost the same, but more toppings would cost less at Nathan's. So if you wanted more than 2 toppings, you'd then want to go over to Nathan's because his toppings are less expensive. Awesome. And our last one, Nathan and Olivia decide to go bowling. The cost for Nathan to play is $4 per game. That word per always shows up. Per is your multiplier. You know that per is going to be the word that means that 4 is the slope. Okay. The cost for Nathan to play is $4 per game plus $2 to rent shoes. When you rent shoes, it's a one-time thing. So Nathan's equation is just y equals 4x plus 2. $4 per game plus that additional $2 for him to play. Whereas Olivia's cost, because she's younger, let's say, so the prices are different, it's $5 per game. It's more expensive for her to play, but it's only $1 for the shoes. So Olivia's equation would look like y equals 5x plus 1. I do have a graph here. So if you want to graph on your own before pressing play and seeing what my graph looks like, go for it, take a moment. Otherwise, this is what the two graphs would, sorry about that. This is what the two graphs would look like. And we would see right away that they have an intersection. These lines are really close together. The first equation is y equals 4x plus 2. It starts at a y-intercept, of 2 and has a slope of 4. My point is in the right spot, but this is not right. My apologies. So a y-intercept of 2 and a slope of 4. Whereas the second equation for Olivia has a y-intercept at 1 and a slope of 5, and it meets exactly at that same point. So that intersection is at 1, 6. whereas these are both equations are set equal to y, so they're beautifully set up for substitution. Since y is equal to 4x plus 2, that means where I see y in my other equation, I'm going to substitute in 4x plus 2. So we have 4x plus 2 is equal to 5x plus 1. Subtract 4x on both sides. Subtract 1. End up getting x equals 1. I would then plug this one into either one of these equations to solve for y. I chose the first one. And when I plug in a 1, I end up getting y equals 6. And we already knew that. We knew the solution was 1, 6. Which means that if they each play just one game, it's the same cost. It would both cost them $6. But after that, since again, Nathan's game cost is only $4 per game, it would be cheaper for him if he played more than one game. I know this is a lot of information. I know I went pretty quickly. Feel free to go back and rewatch and